This is the AB 4-3 review. Calculators are allowed, though it's unlikely that you will need them. So for each of these, we want to find the value of x, where f has a local min, a local max, and a point of inflection. And we're dealing with a function whose derivative we already know. So we know that local mins and local maxes occur when the first derivative changes sign. So we can figure out what the critical values are simply by setting this f prime equal to 0 or undefined. By doing that, we can do a sign chart for f prime and see that -2 will be a 0, as will +4. If I analyze the sign of f prime in between each of these intervals, then we can determine whether we've got maxes or mins. So prior to -2, say at -7, this will be a negative number, but then we square it so it becomes positive, and this will be negative, so the whole output for the derivative will be negative. After -2 and before 4, say at 0, this will be a positive value, and this will still be a negative, so we'll end up with a negative. Notice that we did not change sign at -2. If I look after 4, then this will be positive and this will be positive, so both will be positive. Looking at this picture, we can see that the only extreme value I'm going to have is at x equals 4. So I will not have a local max at all. But the value of x at which I have a minimum will be x equals 4. Now, in order to find the point of inflection, I have to take the second derivative. So taking the second derivative, I have an option. I can either multiply this all out and then take the derivative and then refactor, or I can use the product rule with the chain rule and just write my second derivative. So I'm going to choose to do it using that method. I have an x plus 2 squared times a 1 plus an x minus 4 times a 2 times an x plus 2 raised to the 1 times a 1. If I'm interested in finding out when that second derivative is 0, that means I want to be able to factor this. So again, I'm at a crossroads. I can multiply everything out, combine my like terms, then factor, or I can use the fact that this is already partially factored for me and see that there's an x plus 2 in common. So if I pull that x plus 2 out, then I can write what's left over. In this term, when I pulled out an x plus 2, I was left with another x plus 2. With this term back here, when I factored out that x plus 2, I'm left with a 2 times an x minus a 4. So if I multiply that out, I can see I'll have an x plus a 2x is a 3x, and I'll have a 2 minus an 8, which is a -6. So I can finish factoring and see that I can pull out a 3. And now I see that my second derivative is going to have zeros at -2 and +2. So over here, I can now do my sign chart for f double prime. I have a sign change, or not a sign change, a 0 at -2, and I've got another one at +2. Prior to -2, say at -3, this would be negative and this would also be negative. Between -2 and 2, say at 0, this will be positive, this will be negative. And after 2, they'll both be positive. So now looking here, we can sketch the picture, and we can also talk about when we have inflection points. We know that we have inflection points whenever the second derivative changes sign and the first derivative exists. Since we've got no problems with our first derivative, we just need to look and see when we have sign changes. So it will occur at -2 and at +2. So just to confirm, using a picture, we can see that we are falling on a smile, excuse me, which is the left side of a smile. Then we flatten out, and then we fall on a frown, which is the, let's see, if I'm falling on a frown, that's the right side of a frown. Then at +2, I'm going to have a change and start smiling, but I'm still frowning. And then at 4, I start to rise on a smile. So we can see that we had an inflection point here, and then we had another inflection point here. We changed from a smile to a frown, and from a frown to a smile. But we can also see on this sketch of F that I had only one extreme value at 4.